Alright guys, let's start a new day out today. I'd like you guys to get out your Cornell notes, get those ready, get this title down, get this I can statement down, and don't forget the date in the top right hand corner. Go ahead and pause the video to do so if you have not already. Also, feel free to pause this video at any time while we're moving along, because I'm probably going to be moving a little faster than you're writing. So please use that pause feature on this video. Alright, so today we're going to talk about zero and negative exponents. By the end of today, I'd like you guys to be able to apply the laws of exponents to expressions and simplifying them, basically. Okay. So let's get down this definition first. Zero as an exponent. It says for every non-zero number, a raised to the power of 0 is 1. Basically, what that's saying is that any number that's not 0 that has the power of 0 on it will equal 1. Let me show you what I mean. 4 to the power of 0, that's a non-zero number, 4. 4 to the power of 0 equals 1. That's what this definition is. Here's another example. Negative 5 raised to the power of 0. Well, that's a non-zero number raised to the power of 0, so the answer is 1. Z to the power of 0. As long as z is not equal to 0, then this is 1. 1.23 raised to the power of 0. Doesn't matter how complex the number is, as long as it's not 0 raised to the power of 0. 1.23 raised to the power of 0 is 1. Right? That's what happens when 0 is an exponent. So let's take a look at some other things. We're going to use what we know about exponents so far to actually start talking about 0 and negative exponents. 2 to the 4th power, we know can be written as 2 times 2 times 2 times 2. Basically, that means times 2 4 times. Right? 2 times 2 is 4 times 2 is 8 times 2, which is 16. If you don't believe me, pull out your calculator and type it in. Okay, my calculator doesn't want to turn on. There it is. We're going to do 2 to the power of, this is what we call the caret key right here, 2 to the power of 4. There we go. 2 to the power of 4 is 16, just so you guys have that proof. 2 to the power of 3 is 2 times 2 times 2. 2 to the power of 3 is going to be 2 times 2, which is 4, times 2, which is 8. 2 squared is 2 times 2, which is 4, which means 2 to the power of 1 is just 2. And we just talked about how 2 to the power of 0 is 1. I wonder if you guys can see a pattern here. 16 to 8, 8 to 4, 4 to 2, and 2 to 1. There's a pattern here. Each time we're dividing by 2, and it just so happens to be that our base of all these expressions over here is 2. Every time we're dividing by 2. So I wonder if we can use this pattern to tell us what 2 to the negative 1 power is. Well, 2 to the negative 1 power, if we follow the pattern, all we should have to do is divide by 2. Well, what is 1 divided by 2? 1 divided by 2 is 1/2. Right? And to continue on, 2 to the negative 2nd power, let's continue that pattern. Let's divide by 2 again. 1/2 divided by 2. Hit my BC button here. 1/2 divided by 2 is 1/4. 2 to the negative 3rd power, divide by 2 again. 1/4 divided by 2. That BC button again. 1/4 divided by 2 is 1/8. I believe, yeah, 1/8. And then divide by 2 again to find 2 to the negative 4th power, which is going to give me 1/16. You guys might notice here, 2 to the negative 4th just so happens to be 1 over 2 to the 4th. And we'll get to that in just a second. And that actually is my definition of what negative exponents are. Take a look at that. Let's write down this definition. It says negative exponent for every non-zero number, a, and an integer that is just some whole number or negative number, n, a to the negative n equals 1 over a to the n. And what that means is if I have a number that is like this one, 5 raised to the negative 2nd power, I can just write that as a fraction with 1 in the numerator, and then the denominator, change that negative 2 to a positive 2. Okay, so basically if I want to, if this is not happy where it's at, it is in the denominator, in the numerator, and it is over 1, I can just move all of this thing down to the denominator and just change the sign on the exponent. Okay, let's take a look at this one. Negative 3 raised to the negative 4th. Well, according to my rule here, I can write it as a fraction and put the negative 3 to a positive 4 in the denominator. Let's leave a 1 up top. This also simplifies. And if you're not sure what negative 3 to the 4th power is, pull up your calculator. It says negative 3. Make sure you use those parentheses like it has, negative 3. Caret sign for the power, the 4th power. That's 81. So this is going to be 1 over 81. And lastly, 1.2 raised to the negative 5th power. Well, this would be the same thing as writing 1 over 1.2 to the 5th power. Now, lucky for me, I have a calculator. 1.2, 1.2 raised to the power of 5 gives me this long number. 2.488. You can just say 2.49 by me. I'm happy with 2.49. We're round it to the nearest hundredth there. All right. So let's use the same property and apply it to my powers with my base of 3 here. 3 to the 4th power. I'm not sure. Use your calculator. 3 to the 4th power is 81. 3 to the 3rd power is 27. 3 to the 2nd power is 9. 3 to the 1st power is 3. 3 to the 0 power, we just learned, is 1. So 3 to the 1st power must be 1 over 3 to the 1st power. That means, well, 3 to the 1st power is right here. That's just 3. This is 1 over 3 to the 2nd power. So 1 over 9. This should be 1 over 3 to the 3rd power. It's going to be 1 over, well, 3 to the 3rd power was 27. So 1 over 27. And lastly, this is going to be 1 over 3 to the 4th power, which is 1 over 81. So we can use what we know about positive exponents to help us figure out what the negative exponents are. And you'll notice that just because we have a negative exponent doesn't mean we have a negative answer. Okay, and that is the key point right here. Negative exponents do not mean negative numbers. They do not mean negative numbers. They mean fractions. So let's get through some examples here so we can start working on those exit tickets of yours. Let's solve these ones. If you guys want to go ahead and try it, pause the video now and give each of these a try and then play it again to see if you got them right. 6 to the negative 3rd power. Well, from what I've learned, this can be 1 over 6 to the positive 3rd power. And that's going to be 1 over 6 times 6 times 6. Let's figure out what 6 to the 3rd is. 6 to the 3rd power is 216. There's that answer right there. 3 to the negative 7th. Let's rewrite that. 1 over 3 to the positive 7th. That's going to be, got 3 here. 3 to the positive 7th. Which is 2,187. Glad I didn't have to do that in my head. 2,187, so that's going to be 1 over 2,187. Next is n to the negative 7th. Remember, as long as n isn't equal to 0, I can rewrite this as 1 over n to the positive 7th. And because I don't know what n is yet, no one's told me what it is, that's as simplified as I can get. And just so we know, if I ever have a negative exponent, it's not simplified. So if you're ever asked to simplify an expression that has a negative exponent, you've got to get rid of that negative exponent and make it positive. All right, looks like I've got 3 more examples here. I think after a couple more examples on the next page, you guys should be good for the exit ticket. All right, we've got 2 factors here in this first example, 2 factors, and I'm going to take this 2 factors at a time. I'm going to write this as a fraction. We can write anything over 1. I want us to remember that if it has a positive exponent, we don't need to move it. It can stay where it's at. So with that being said, 3 squared stays where it's at because that's a positive exponent. But d to the negative 2nd power needs to move. And that's going to go join the 1 down here. This is going to go straight down to the denominator. But I can give it a positive exponent so it's simplified. Simplify this one more step. 3 squared is 9. I don't know what d squared is, so I'm going to leave it like that. Next problem. Why don't you go ahead and give this one a shot right now? Pause the video and give it a try. All right. You'll write this as a fraction really quick. Go 1 factor at a time. 3 to the negative 2nd power means it needs to move. Because it's in the numerator, it's going to move down to the denominator. 3 squared, though, with a positive exponent. Now I'm going to move my m to the 4th power. Not really, though, because it has a positive 4th power. So it's actually going to stay there, m to the 4th up at the top. This does simplify, though. M to the 4th over 3 squared is 9. All right, this next one uses a little bit of know-how on the exponents. If you think you know how to do it, go ahead and give it a shot. Pause the video and come back. Right, hopefully you guys recognized that this exponent is actually touching whatever is inside the parentheses. These parentheses are important. Basically what happens here is the distributive property of exponents. This can be rewritten as 2 to the negative 3rd power times n to the negative 3rd power. Okay, so I'm going to rewrite my fraction here because I see some things are going to have to move. 2 to the negative 3rd moves down to the denominator, but so does n to the negative 3rd. Oops. I'll erase that really quick. And both of these should turn into positive exponents because they are being moved down to the denominator. It does simplify a little bit more than that. We know what 2 to the 3rd power is. We looked at that earlier. That's 8, and then times n to the 3rd power. All right, let's take a look at the next slide, and we should call that good. All right, same thing applies here. Rewrite this as a fraction, and I'm going to go 1 factor at a time. The 1 stays up in the numerator because it doesn't have a negative exponent. And the denominator does have a negative exponent, though. To get rid of that negative exponent, guys, we need to move that up to the numerator and give it a positive exponent, leaving a 1 down in the denominator. So basically, we can just write this as, well, 1 times x squared is just x squared. X squared divided by 1 is just x squared. So 1 over x to the negative 2 is x squared. All right, why don't you use that same knowledge and do the second one? Give it a try. Pause the video and give this one a shot. And hopefully you wrote it as a fraction. The 2 should stay up at top. And the m to the negative 3 needs to move up top, leaving a 1 down in the denominator. And anything divided by 1 is just itself. So 2 times m to the third power is our answer. And lastly, this is the champion of all problems for today. If you can do this one, you should be able to do the exit ticket. We're going to go one factor at a time. This factor right here is going to move down to the denominator because it has a negative exponent. This one right here is going to stay. And this one right here is going to move up because it has a negative exponent. And I'm just writing the m first because it's alphabetical order. You can write the n to the fifth first if you want to. So this is going to be m squared n to the fifth all over 3 squared, which is 9. Guys, and that's how you simplify exponents. We'll look again a little bit more in depth on how to simplify exponents tomorrow. A couple more difficult problems. I wouldn't consider them difficult. They're just harder than these ones. So go ahead and get that exit ticket done and turned in before you leave. Good luck, guys.